Welcome back. Today we're going to be going over another example in preparation for your AP Statistics exam. This one specifically is going to be for confidence intervals between two population proportions specifically. So let's jump in. All right, so the question says a study finds that in a sample of 3,200 births in country A, 38% were delivered by C section. In another sample of 2,800 births in country B, 42% were delivered by C section, right? So clearly in country A, it was a bit less, a few less C sections than um, country B proportionally based on the samples that were provided. So here we're asked to calculate a 95% confidence interval for the difference in the proportions of C section births between country A and country B. So let's review what is the data given. So for country A, the data given is that the population size here, or sorry, not the population size, the sample size for country A was 3,200. And then for P1 hat, it is 0.38 because 38% of these women ended up delivering by C section in this case. Then we have B, right? For country B, it was a sample of just 2,800 births. And in this case, 42% of the women delivered by C section. So P hat, P2 hat is going to be 0.42. And there we go. All right, so the confidence level is 95%. So that means the other value that's very critical here is the Z value associated. The critical value associated is 1.96 for 95% confidence intervals. All right, so let's actually do that. Let's calculate that 95% confidence interval. To do that, it's going to be P1 hat minus P2 hat, so the difference between them, plus or minus the critical value, which is 1.96, and then times the square root of P1 hat times 1 minus P1 hat divided by N1, and then plus P2 hat times 1 minus P2 hat over N2. Okay, so now I'm going to punch all this in, and we're going to find that confidence interval, and then I'll talk a bit more about what this means. Okay, so P1 hat, that's going to be 0.38 minus 0.42 plus or minus 1.96 times, let's see, 0.38 times 0.62 divided by N1, and then plus P2 hat, so 0.42 times 0.58 over N2, which is 2,800. All right. And then let's simplify that even further. So here we're going to get negative 0.04 plus or minus this entire part. I'm just going to skip ahead. For this one, it's going to be times 1.96, and then the entire number under the square root sign. If we take the square root of that, we're going to get 0.0127, and then that's going to give us negative 0.04 plus or minus 0.0249. So thus our confidence interval is negative 0.0649, comma, negative 0.0151. And so therefore, we can be 95% confident that the difference in the proportions is somewhere between negative 6.49% and negative 1.51%. Okay, so then the next question asks us that based on this confidence interval, is there significant evidence that these proportions of C-sections between the two countries differ, right? Because at the end of the day, there's always going to be some sort of natural variation. So even if it was the same, likely we would have, we would end up with some some variation naturally. So the question is this a case of just some natural variation? Is that why we got different numbers? Or is do perhaps some of the one country's practices or lifestyle or other factors like that actually influence the number of C-sections that that country is having over another country? And in this example, the answer would be that it is statistically significant. Yes, there is significant evidence that the proportions of C sections between the two countries differ. And why is that? I want to explain why. It's because in this 95% confidence interval, zero is not a part of this, right? It's between a 6.49% difference and a 1.51% difference. And we can be confident that that is the case, that we can be 95% confident that the true value falls within this range. And so since zero is not actually in that range, right, you know, even the smaller part of the range here, with it, the part where it differs less, it does not quite pass zero, right? And so therefore, because of that, we can say that there is significant evidence that the proportions differ because we would need zero to be a part of the confidence interval in order for us to conclude that there isn't enough evidence to suggest that it could possibly just be natural variation potentially. Now, as always, if you do have any questions, feel free to leave those down in the comment section, and I will see you for the next one.